So this is the graph of sine x. So let us write this down. So this is a graph of sine x or sine theta. So you see at 0 it takes value of 0. So you have x is 0 and y is 0. And at pi by 2 it takes value of 1. So notice that you have pi by 2 here takes value of 1. Then at pi it takes value 0. At 3 pi by 2, here is 3 pi by 2. Yeah, it takes value minus 1 as you can see. And then at 2 pi it takes value 0 again. So this is the sinusoid curve. You can see the same thing happening in the negative direction. So this is minus pi by 2 here. It takes value of minus 1. Then at minus pi it takes value of 0. And then it becomes positive at right here. And at minus 2 pi it becomes 0 again. So this is minus 3 pi by 2. So you can notice the symmetry. So this is the graph of sine theta. So this is the graph of cosine theta. So at 0 it takes value of 1. Yeah, again at pi by 2 is right here, it takes value of 0. As you can see right here, at pi it takes value of minus 1. Then again at 2 pi it takes value of 1, you can see here. And then you can see at this is 3 pi by 2 here. So you can see at 3 pi by 2 it again takes value of 0. In the negative direction you just operate by symmetry. Again this is minus pi by 2. And at minus pi it again takes value of minus 1. And minus 2 pi it takes value of 1. And it takes value 0 at minus 3 pi by 2. The beauty of cosine theta is the graph is symmetric about the y-axis. So see that whatever is on this side, this graph is same on this side. Yeah, so you can actually fold it over like a mirror and it looks exactly the same. Yeah, notice that minus pi by 2 takes the same value, minus 3 pi by 2, 3 pi by 2 the same value, 2 pi, minus 2 pi same value. So such graphs which take, both sides are mirror opposites of each other, they're exactly the same. They are called even functions. On this slide, we discuss the graph of tan theta. So this is the graph of tangent theta. So let us write this down. So notice the properties. So at 0 it is 0. It is 0 again at pi. It is 0 at 2 pi. It is 0 at minus pi. It is 0 at minus 2 pi. So it is 0 precisely where sine theta is 0. And it is also asymptotic to pi by 2 and minus pi by 2. So look, it is asymptotic here. This is because cos pi by 2 goes to 0. So very close to pi by 2, the tangent graph becomes closer and closer to infinity, or it becomes a huge number. So it becomes a bigger and bigger number as we approach pi by 2 or minus pi by 2. You can see this in the graph right here. So look on pi by 2 how this graph is approaching. This is pi by 2 here, and you can see how the graph is approaching it. Similarly at minus pi by 2, how this graph is approaching. Yeah, so this is minus pi by 2 and this is pi by 2. Now you repeat the same set here, so you can see this copy of the graph is now repeated again in this interval. From pi by 2 to 3 pi by 2, you have exactly the same copy from minus pi by 2 to pi by 2. So this copy is taken, you copy it and you put it right here. So you can see these two copies are same and so on. Yeah, similarly on the left hand side. So just stop for some time this video and see for yourself and try to get the idea of what the tangent graph looks like. So this is a graph of cotangent x. Or cotangent theta. So you can see it is 0 at pi by 2, 3 pi by 2, 5 pi by 2, and on the negative side on minus pi by 2, minus 3 pi by 2, minus 5 pi by 2. So it is 0 precisely where cosine is 0, because cot theta is cos theta over sine theta. So wherever cos theta is 0, cot theta is also 0. Just like tangent theta, it is asymptotic to the points where sine theta is 0. For example, sine is 0 at 0. So close to 0, the graph becomes asymptotic. Similarly at pi, the graph is sine pi is 0. So closer to pi, the cotangent or cot theta becomes infinite. So let me mark this down. So you can see closer to 0. So close to 0, cot theta becomes infinite, and close to pi, cot theta becomes infinite. And this is the fundamental graph here, and everything else is just a copy. So you take this copy of the graph here and just copy it here and then here and on the negative side. So you're just taking this copy from 0 to pi and pasting it. So that is all about cotangent theta or cot theta. So this is the graph of secant theta, which is 1 divided by cos theta. So let us write this down. So this is secant theta, which is 1 divided by cos of theta. So at 0, cos theta is 1, so you get 1 here. And then at minus pi by 2 and pi by 2, cosine becomes 0. So secant theta approaches asymptotically to them, or it becomes infinite. So secant theta becomes extremely large close to pi by 2 and minus pi by 2. You can see this here and right here. Similarly, you have this graph here, and at minus pi you get minus 1 here, and then at minus pi by 2 and minus 3 pi by 2, cos theta becomes 0. So it becomes asymptotic to these two lines. And again you can see this is the fundamental graph here, and it is just copied on other sides, and then obviously it becomes negative here on this side. And that is it. You can spend some time on it, looking at it, understanding how it is behaving. So this is a graph of cosecant theta, which is 1 divided by sine theta. So this is 1 divided by sine of theta. So this is 1 at pi by 2. As you can see, it is here 1. And wherever it goes close to 0, where sine theta goes close to 0, it becomes infinite. And similarly at pi, it becomes infinite.
On this slide,
because
we talk
sine
about
theta
two
goes
problems of
close to
induction
0.
which
So you
involve
can see that
fractions.
it becomes close to infinity right here.
So we will show that the following
then on
statement
this
is
side.
true. Here the
Similarly,
following statement
for
Pn
sine
is true.
minus pi by 2
So
is
1
minus
divided
1.
by 1
So
times 2,
cosecant theta is
then
also
1
minus 1 here.
divided
And
by
then
2
close to
times
0 it
3
becomes
plus
infinite.
1 divided
And
by
here
3
again close
times
to
4
minus pi it becomes infinite. And this is the copy.
plus all the
This
way
is the
to
fundamental copy of the
plus
graph.
1 divided
And you
by
tile the entire plane
n
with
times
this
n plus 1.
period everywhere.
This is
So
equal
this is
to
the graph of cosecant theta.
n divided by